Hello, welcome back. So the next technology we are covering is the pattern matching bots. And the basic idea you have seen in the very first lecture when I talked about ELIZA. ELIZA had an engine that could read in a script. And the most famous, most popular script was the doctor script, which simulated this conversation with a psychotherapist. So the user could type in something like, I am very unhappy these days. And then you get a response that reuses some of the words from the question. How long have you been very unhappy these days? And I told you how it works. ELIZA scans for keywords. Then when it finds certain keywords, it will apply a pattern to the input sentence. So like the pattern I am followed by something. And then for decomposition pattern, there are associated reassembly patterns where it inserts whatever it found here into the answer, possibly with some minor changes. So the way these scripts look like, you can see here. So we have patterns in here. How this works, we'll talk about in a minute. And then if this pattern is matched, it will generate one of these answers. So very often for one pattern, you have multiple answers. So even if the same pattern is matched multiple times, it doesn't give the exact same response. So one of these here is picked at random. So you can see when you talk about your mother, then there's a number of possible responses that can be generated from it. So what we have in here, these references are of course regular expressions, and this is one of the main technique behind pattern matching bots. So as a programmer, software developer, you have to know regular expressions, and if you remember your undergraduate computer science theory classes, you know that they in turn are an implementation of so-called finite state machines or deterministic finite automatons, DFAs. So there's this hierarchy of machines, starting from logic over finite state machines, push-down automatons, and then the Turing machines, which can basically compute anything that you want a computer to be able to compute. So finite state machines and therefore regular expressions are not nearly as powerful as a Turing machine, but they are still very useful in many applications. So you should know how regular expressions work. If not, look it up. So the basics are shown here. You can have a Boolean or an expression. For example, if you want to match different writings of the word gray, you can say or, and then this expression here will match both of these possible versions of writing it. You can use parentheses to scope operations and also to capture groups that you'll later use in the output. So here, for example, you can use gray and gray, or you can just have a limited group in here where you just say these variations of the letter. And both of these regular expressions will match the same input. So either gray or gray. And then, of course, you have the quantifiers after a token. And this tells you how often the element can occur. So a question mark means 0 or 1. An asterisk means 0 or many. The plus sign means 1 or more. You can have in curly braces a number that says it must be matched exactly n times. And you can also give a range from min or more, or from min to max. So these are just the basics, but again, refresh your knowledge about regular expressions. Here we are interested in using regular expressions for matching natural language text. And there is a small exercise, task 2, on the worksheet. And after you're done, I'll see you in the next lecture part.